Hello, this video is supposed to be your homework for January 7th and 8th for AP Physics 1. So this video is supposed to assist you with concept from last semester, which is called conservation of energy, which is energy concept period. In AP exam, they will have a lot of these concepts on the test. So let's go ahead and interpret what's going on. So basically I'm going to combine this one with the kinematic one because these are the two most important topic appeared on it, the AP exam. So basically let's interpret this one. So the box itself has the mass. I'm just going to say mass 1 is 1 kilograms. And this is the original position, which is that. And the spring is being compressed as how much? We don't know. That's what you're looking for. Basically, the box itself is attached to the spring, so therefore it's a spring constant. I'm just gonna put it like 10. It's only 10, okay? That's the spring constant. So let's draw it again. This is a table. So basically, once you compressed the box with the spring this much, and then eventually you released, the box will keep moving with the kinematic equation, and eventually it will land over here. So in order for you to apply the kinematic equation, you must know the height. I'm just gonna say it's 10 meter also. Okay, the height is 10 meter, the spring constant is 10. And then we're gonna have to figure out how fast the box is moving. Oh, and also with this one, we must know the displacement there. Now let's forget about the spring constant at this point in time. Just pretend like the box is moving along the table, and eventually it moves down the table with that gravity. And eventually you know this one. So I'm just gonna say this one is about 15 meters. Okay. So now we want to figure out the time it takes from this object, which is the height of 10 meters, to drop down to the target, which is 15 meters away from the original position. So we're gonna have to use the kinematic equations. So let's start over here. So I'm just gonna say kinematic equation. So we have this. I'm just gonna give you 3 different equations, and then from there we figure out which equation we want to use to solve certain problem. Okay. You can see 3 different equations, right? Yes, you can. So you know the height. You can figure out what the time from there. Also, yeah, this one the height, you don't know time, but we're looking for time. We need the time in order for us to calculate for the initial velocity in the x direction. So I'm just gonna say, to get time, I'm using this equation. Plus 1/2 t squared. So basically over here, I'm just gonna say use 10 for gravity. So gravity is equal to 10. That one, remember there's no acceleration in the velocity in the y direction, is equal to 0. You only have Vox, which is what you don't know. That's what you're looking for. So let's replace the number. The height is 10 time. So basically your time is square root 2. let me explain how I get square root 2 by erasing this one first, okay? So basically, this is 10, this is 5t squared, and then 10 over 5t squared. And then that will be square root of 2. That's your time. When you figure out how much time it takes from the object to drop from here to here, you can use that time to figure out the distance in the VOX. The distance is how much? 15. VOX, that's what you're looking for. The time is square root 2. So now, we're trying to figure out what VOX is, so we're going to have to divide this one by itself on both sides of the equation. So VOX is equal to 15 square root 2. That's your initial velocity. That's your time. You don't need this, you must know the time in order for you to figure out what the initial velocity is. And then from there, this is a little bit backwards. So basically we're solving backward to forward. So now we go back to where we have over here. This is basically what the box is, right? The box itself is actually moving at the velocity of 15 square root 2. That's what it is. But now we're trying to figure out what's the displacement that give off that velocity. So you're gonna have to use the concept of potential energy is equal to kinetic energy. So replace this one with 1/2 kx squared, 1/2 mv squared. Get rid of that because it's the same term. This one, x squared is equal to x divided by x. So mv squared divided by k. So this is your displacement square. Is equal to mv squared k. So your displacement is equal to square root mv k. So now I'm just gonna replace the number. What's my mass? 1 velocity, which is what we have, 15 square root 2 square divided by 10. Whatever you have, that's your displacement. Then you're gonna have to simplify those terms yourself. So for this reason, just leave it that way.